A very good day. Today, me and my group would like to present on our topic, which is the bending test. So, on our first slide, we have our agenda, which is firstly the introduction to bending test, second, principle of bending test, third, type of bending test, fourth, industries involved, fifth, importance of bending test, sixth, characteristics of testing and data produced, seventh, graph of the testing, eighth, video of mechanical testing, ninth, problem using the bending test, and last but not least, conclusions and recommendations. Moving on to our next slide, which is our introduction. The test is the bending test is one of the most widely used mechanical tests to determine flexural strength and stiffness of materials. The test simulates conditions in which materials are subjected to bending loads during real-life applications such as in beams, panels, and structural components. Secondly, we have our principles of bending test. What is a bending test? Principle behind the bending test is simple. A force is applied to the material while it is supported at certain points, causing it to bend, and we observe how much it bends, at what point it either yields or fractures. The test helps determine mechanical properties like flexural strength, modulus, and fracture behavior. Moving on to our next slide. Types of bending tests. We have 3-point bending test, 4-point bending test, and last but not least, cantilever bending test. So there are some statements in the 3-point bending test, which is the test a specimen is supported at 2 points and load is applied at center. It's commonly used for materials like metals and ceramics to determine the flexural strength. Secondly, for 4-point bending test, specimen is supported at 2 points and 2 loads are applied at equal distances from the center. This method is often used for composite materials to assess their behavior. Last but not least, for the cantilever bending test, it states a specimen is fixed at one end and load is applied at the free end. The test is useful for evaluating the bending properties of material in cantilevered structures. And we have, in the next slide, we have the diagram of the 3 types of tests which I've just stated just now. Next, the industries involved. The test is widely used in many industries. Firstly, we have the construction industry to test beams, concrete, and reinforcement bars. Secondly, the automotive and aerospace sector. It used for implementing for frames and composite parts. Thirdly, the medical sector like implants and prosthetics. And fourth, electronics for flexible printed circuit boards. And last but not least, the packaging industry to test materials like cardboard or plastics. In the next slide, the importance of bending tests. In this slide, it states that the bending test provides important information for engineers and designers. It helps determine how much force a material can withstand before it bends or breaks. This ensures that the selected materials is safe and reliable for real-world applications. By understanding the material's response to flexural stress, engineers can predict its performance in actual use. In addition, the data collected supports compliance with industry standards and helps in material certification. In the next slide, we have the characteristics of testing and data produced. From a bending test, several important mechanical properties can be obtained. Firstly, we have the flexural strength, the maximum stress experienced before failure. Secondly, modulus of elasticity, which is also known as flexural modulus, a measure of a material stiffness in bending. Thirdly, yield point and fracture point, identifies the limit where permanent deformation or fracture occurs. And last but not least, the deflection. It states that how much the material bends under load. These values are crucial in deciding the suitability of a material in a specific design. And the next slide, graph of the testing. During the bending test, we usually record a load versus deflection graph. This graph shows how the material bends as the force increases. There are typically 3 zones, which is the elastic zone, where material returns to original shape when the load is removed. Secondly, the plastic zone, permanent deformation begins. And last but not least, the fracture point, where the material breaks. This method helps us understand a material's behavior under stress and identify its strength and flexibility. The next slide, we have our graph here, which shows the load versus deflection curve in bending tests, and also the steps, as you can see at the next to the graph is stated. That is for the further reference on understanding how the load versus deflection curve in a bending test works. The next slide, we have prepared a video of mechanical testing. So the video demonstrates a standard 3-point bending test on a rectangular specimen. The test continues until the material fractures or reaches its maximum deflection point. The next slide, we have our advantages and disadvantages. So for the advantages, a simple setup and cost effective. Secondly, can be non-destructive if done within the elastic range. Last but not least, applicable to many materials such as polymers, metals, and other composites. So for the disadvantages, it is sensitive to defects like surface cracks, less suitable for very soft thin materials, and also accuracy depends on correct specimen preparation and setup. On the next slide, the problems faced using the bending test. Some challenges we may face is including the misalignment of the sample. Secondly, material anisotropy, which means different properties in different directions, and environmental conditions such as temperature and humidity. Last but not least, incorrect support span or machine calibration. All this can affect the results and must be controlled and monitored. The next slide, we have also stated our conclusions and recommendations. To conclude, the bending test is essential and crucial to evaluate a material's mechanical performance under flexural stress. It helps ensure that materials are safe, reliable, and suitable for their applications. So we've also listed few suggestions for improvement, such as implementing and following standards like ASTM D790 or ISO 178. Secondly, combined with other tests like tensile or impact tests. Last but not least, ensure consistent sample preparation and test conditions. So we have listed few references. This is for your information. You can click it and surf it through the net if you would like to know more about our bending test. And thank you for your precious time for listening to me and my group on our topic, which is bending test. Have a nice day.